Hi guys, just a couple more examples right here. Number 18, we sort of did this one in class, but I just wanted to tell you again, it's actually a lot easier than it looks. All right, so right here, again, one thing you just don't want to forget is rate times time equals distance, and as long as you got that, it's not too bad. Christy plots her plane for 360 miles against a headwind in 3 hours. So she's going against the wind right here. The flight would take 2 hours and 24 minutes with a tailwind of the same speed. Find the headwind and the speed of the plane in still air. Okay, so right here, it's against the wind, it takes 3 hours. With the wind, it takes 2 hours and 24 minutes. So what we're going to do is we're going to say right here, we know we have right here a distance of 360 miles. All right, we have an airplane right here. So first of all, when we're flying the plane, first of all, we have something, so it's going against the wind right here. The wind's going against it. So that's why right here, the time is going to equal 3 hours. The distance is still going to be 360 miles per hour. 360 miles. But we do not know the rate. And we also don't know how what the speed of the wind is. What we also know is right here, if we have this same plane going this direction right here, okay, we have now the wind going with it right here. So that's pushing on it. In this case, the time is 2 hours and 24 minutes. Now let's put that into a decimal. I know that minutes there's 60 minutes in an hour, so 24 out of 60 is going to give me 0.4. So that will end up being right here, my time is going to equal 2.4. All right, my distance is still going to be 360 miles. That did not change. And we still don't know the rate right here, okay? But here's what we do know about the rate. In this case right here, it's pushing, we have something push against it. So in this case, we're going to say the rate, we're going to say right here, first of all, it's going to be a lower rate because we have wind pushing it. So it's R minus X, where X equals the wind speed. In this case, we're going to say R plus X because we have like the wind right here is pushing, like is actually pushing the plane, it's helping it. All right, no problem. So right here, what we want to do is figure out right here, what is that rate and what is that, wind speed. So no problem, we'll go ahead and say that rate times time equals distance. So this right, we'll say R minus X times the time, which is 3, equals the distance is 360. And in this one right here, we're going to say that this rate, which is R plus X, times the time, which is 2.4, equals the distance, which is 360. Okay, no problem. So a couple ways you can kind of think about that. You have a couple options right here. One way you could think about it is solving for R minus X and R plus X, and then doing it as a system of equations. Or you could just solve for one of the variables. One thing, this is how I personally would do it. I would go and say, okay, no problem. I'm going to divide by 3 both sides right here. So R minus X right here equals 120. Right here, I'm going to divide by 2.4 right here. So R plus X equals 360 divided by 2.4, 150. Now we have actually we could easily use elimination for this. R minus X is 120, R plus X is 150. All right, and now the reason I did this is I saw, oh, that's easy because now we have same number, different sign right there, or opposites, I should say, different opposites right there. So I could say R plus R is 2R, this cancels out. 120 plus 150 is going to be 270. And just divide by 2 right here. So we end up right here with let me change this. R equals right here, 270 divided by 2 is 135. So we know the rate is 135, and to get x, we just say, okay, r plus x equals 150. That's right here, 135 plus x equals 150. And x right here equals 150 minus 135 is 15. So there we have it right here. So to answer this question right here is, sorry, wrong problem. See right here, the speed of the headwind of the plane, as we said right here, speed of the headwind of the plane is 15 miles per hour. And it was right here, the actual R though that we got right here is 135. So, so the speed in still air is 135 miles per hour for both of them. Okay, so that was 18. Not too bad. A little bit easier than it seemed like in class, I think. Let's look at number 19. Let me move this out of the way so there we go. It's good. Okay. Right here. Two planes travel toward each other from cities that are 1,220 kilometers apart at rates of 320 kilometers per hour and 290 kilometers per hour. They start at the same time. And how many hours will they meet? Okay, no problem. Let's take a look here. So we have one plane right here. And this plane right here travels at 320 kilometers per hour. Then we have another plane right here. And this plane right here, sorry for this terrible drawing, God. All right, hang on. So this plane right here is, there we go, a little better, I guess, is right here at 290 kilometers per hour. All right, and they started at the same time, and how many hours will they actually meet? Okay, so we're once again going to use rate times time equals distance right here. So the rate is already right here. The time is unknown, right? But the time is going to be equal, of course. And the distance right here, we're going to call that D. All right. The time is going to be the same for both. We'll just call that D. And the distance here, well, we know that they're 1,220 kilometers apart. So this distance, I'm going to say if let's say they meet right here. If this distance right here is D, and the whole stupid thing right there is 1,220, this distance is going to be 1,220 minus D. There we go. Nice. Okay. So here's what we're going to, let's go and map out both of them. Rate times time equals distance. So 320 times T equals right here D. This one right here, we're going to say 290, right? Just making sure, yeah. 290 times time, which is T, equals, and this distance, remember, was 1,220 minus D. Nice, okay. All right, couple ways you can do this. You can go about doing this. You could, one way you could do it is, you could solve them both for T like I did before, or you notice, okay, this is already equaling right here D, right? So I could just plug that in right there. I could say, all right, this is 290T equals 1220 minus 320T. Now, how did I get 320T? Well, 320T equals D. So I just plugged in for D right there. So it's going to give me 290T equals 1220 minus 320T, of course. So I'm going to add 320T on both sides. All right, so that's going to go and give me 610T equals 1220. I'll divide by 610 on both sides. And that's going to give me T equals 2. So we know right here it's 2 hours. And that's all it asked for. It didn't say what distance they will meet right here. So they will meet at 2 hours. If it asked for the distance, that would have been easy too, because we would have just gone and, sorry, if it asked for the distance, we would have just plugged in, would have been no problem. And we would have just plugged in for either this equation or the other equation, and we would have gotten the distance. So it would have been 320 times 2, which is 640. So all good, guys, right here. If it's the distance from here to there, it would be 640. And then the other distance, if it's from the other side to the meeting point, I would have plugged in for the second equation. Anyway, guys, all good. Hope you learned something here, and hope this helped.